When you're listening to music and you want to listen to a specific track right after the one you're listening to right now, you could slot that track into your playlist to play directly after what's playing right now. The track you're playing is not going to just end and then start playing the next one. It's going to wait for it to finish. There's probably going to be a little pause, and then you're going to play the next track. The same can be done in video games. You can do it with music, you can do it with sound effects, and it's very common when working with voiceovers. So how can we do that with Unreal Engine and Wwise? So before we get started, I want to go over some prerequisites for this tutorial, mostly to do with basic knowledge of C++, Wwise, and Unreal Engine, and be able to understand the C++ framework within Unreal Engine. As long as you know that, you should be very comfortable. If you don't worry about it. I should be able to have some resources in the description that will help you move along, or at least learn what you need to learn before understanding what's in this video. What base class do we want for this? So what we're going to do is use a world subsystem. For those of you who do not know what a world subsystem is, it's basically just a singleton instance that allows you to manage many different properties from a global level. And this particular subsystem just survives as long as the world exists. So when the world dies, so does the subsystem. So we're going to grab the header file for this, which is just going to be subsystems world subsystem.h, and then we're going to do the same here, public uworld subsystem. So that's how we're going to start. So let's go over the basic functions that are going to be from world subsystem. So we're going to start with onWorld begin play. World subsystems don't have an explicit begin play, but this is basically a lot of the same thing. Next thing we're going to do is our deinitialize function, which is going to act as our deconstructor in this subsystem. All right, so that makes up all the overrides that we're going to do from world subsystem. Now let's move on to what is going to be our framework for queuing new pieces of audio. So the first thing we need to do is onQueue stuff. So we're going to make this blueprint callable so we can make this accessible from both C++ and from blueprints. And we're just going to call it onQueue. And for now, the only thing that we're going to onQueue is just an event. And since we did not have the header file for AK audio event, we're just going to forward declare it for now, and then we're going to declare the actual header file in the CPP file. All right, the next thing we're going to do is be able to dequeue the next item in our queue. So that's just going to be called dequeue next. And the final thing is we're going to play what we just dequeued. And all we need is just one more variable to cap this off. We need the actual queue itself, which is just going to be an array of events. And that's it. So let's go ahead and make our functions. All right, now that we have made all of our functions, I'm going to do a little bit of pseudocode so you guys can follow along on what we're potentially going to be doing in the future. So let's start with our onQueue function. This one's very basic. We're just going to push the event to the back of the queue. Now we're going to do our dequeue next function. So we're going to check if a new sound is ready to be played, which generally implies the last sound finished and there is something else that's in the queue that's ready to be played. So let's try that. So how we're going to use this dequeue next function is we're going to loop it multiple times to check to see if it's ready to go. So what we're going to do is set a timer from our onWorldBeginPlay function, and then use the deinitialize function to stop that timer. All right, now that we are looping through dequeue next, now we just need to take the next sound from dequeue next and play it. And then the next important thing is to be able to know when we are allowed to play our next sound. So that will also happen from our play function. And what I'm going to do is I'm going to place a little asterisk here because there's multiple ways that we can go about this last step, but we're going to go with a simple one first and then get a little bit more complicated later. But that's it for all the pseudocode. It's not terribly complicated, so I do encourage you to try the code out for yourself, see if you can come up with a solution, and then check back with the video to see how it might compare with mine. But if you're ready to go, let's start with our onQueue function. So we're going to do one safety measure. We're going to make sure that our audio event is at least valid. So we're going to do an if not audio event to check the validity of the pointer. Then we're just going to return. And if it is valid, we're just going to add it to our queue. Nothing much more to that. So now we're going to move on to our dequeue next function. So the first thing is we're going to check if our queue is empty, and if it is, we're going to return because obviously there's nothing to queue. All right, so now we need to know when we're allowed to play the next sound. So we're going to cache a time for that in our header file. So we're going to go back. And below our queue, we're going to make a double, call it next allowed playtime, and just set it to 0 for now. And also, when we do this, it's kind of nice to have a gap between our previous sound and the sound we're playing afterwards. So we're going to make that, for now, a static context spur in our CPP file. We could put this into a configuration if we want, but for now, this works. All right, so that's enough for us to figure out when we need to play our next sound. So now we know that if our current time is equal to our next allowed play time plus the time between queued audio, then we're ready to go to unqueue our next sound. And the way to get our current time is from the world, which thankfully, whenever you have this subsystem, the world has to exist. Otherwise, the subsystem has nowhere to go. So let's get the world. And then from here, we're just going to get a current time called getTimeSeconds. And now we can do our comparison. Once we've done that, we now need to get the event from the front of the queue. So that's going to be our 0th value. And then, of course, we just need to make sure that we've removed that element from the queue. And then all we have to do is play that audio event. So that's the last part. Alright, now that we've done the dequeue next function, we're going to move on to onWorld begin play and deinitialize so we can do our looping call. So first we're going to do super onWorld begin play. That way we always have the call to the parent function ready for us. If we need to remove it later in the future, we can. And then the way that we're going to set the timer is this is also handled by the world in its timer manager. So this does have a lot of overloads. It's not going to be this one. So we need to get ourselves a timer handle, and that's basically our little bit of storage. So that way we can keep track of this timer. So we're going to store that in our header file. And that's just going to be our first argument. The next thing that it's asking for is a timer delegate, and this is going to be our dequeue next function. This is the thing that we're calling every time that this timer loops. So we're going to do that in this function. So we're going to use the ftimerDelegate static function create uObject. This is a safety measure. If the subsystem goes away and this timer is somehow still going, then it will not call this function through create uObject. So it's going to take 2 arguments. It's going to take the actual object, which is going to be this subsystem. And then we need a reference to our function. And that's going to be at, you could do the full class name, but you can also do this class, : and then we're going to do dequeue next. And that's all there is to it. So now we're going to slot this in. And now we need the rate at which the timer is going to be looping. And finally, we just need to tell it that it is indeed a looping timer. And that's all there is to it. So now that we have this, we just need to make sure that the timer stops when the subsystem goes away. So when deinitialize, we're going to do just that. And we do that with the invalidate function right on our timer handle. All right, so that is most of our stuff. All we need to do now is do our play function. So we're going to do one more safety check just to make sure that this event is valid, because we don't want to deref a null pointer. We're going to post ambient. The reason why we're not going to use the typical post event function is because this subsystem does not have a physical location and we can't do anything in 3D space. So this allows us to do a 2D function without any of the positionality that the others would usually do. So it's going to give me some grief because I do not have the audio event header. So we're going to do that now. All right, so now we need a delegate. We don't actually need one, so there's just going to be no pointer. Then we're going to do a callback. We're not doing a callback, so this is just going to be an empty brace. Next is going to be a cookie. We don't need to have any delicious cookies right now, so that's going to be null pointer. Same thing for the callback mess. We're just going to put some brackets, and then we're going to do null pointer for the latent action. And thankfully, the last argument has already been defaulted for us, so we don't have to worry about it. Now that we've played the sound, we need to set the next time that we're allowed to play the next one. The way that we're going to do that is from the sound's maximum duration. First, we need the current time, though. And then we're going to add that current time to our sound's maximum duration, and that's going to be set into our next allowed playtime. And that's literally all there is to it. Let's go test it out. So we can do this in multiple different ways. We can do this through C++ if we wanted to, but to keep things super simple, we're just going to do this through the level blueprints. So on begin play, we're going to get our subsystem. And then from here, we're going to hit the onCue function that we made. And that's going to take an event. I have a bunch of UI sounds that I can use, so I'm going to do number 1. And we're going to do this a few times, so I'm going to just do a couple of copy pastes. And we're going to do number 2, number 3, and number 4. And the result that we want is that this sound plays, then a half second, this sound plays, half second, this sound plays, half second, and then finally this sound plays. So let's see if we got that. Sounds about right to me. So we can leave it there, but there is one little thing that we need to take a look at, and that's going to be our maximum duration. The issue with this is that if you have a random container with several different sounds, then it's going to calculate the maximum duration of the longest sound. So you pick the shortest sound and it happens to be 5 to 10 seconds shorter than the longest sound, then you will be waiting that 5 to 10 seconds before you dequeue the next sound. Large gap. So we need to find a way to know that this sound has just ended. And thankfully we have that. We have an end of event callback. So we need to do a little bit of modification of our post-ambient function. Namely that we need to have a callback now, and we need to know what type of callback it is. So that's the second one. But what's an AK callback func? Okay, so it is a function that returns void, but it has 2 arguments. It has the AK callback type, and then it has an AK callback info pointer. So we need to have a function that fully satisfies that. And we're going to do that as a static function at the top of our CPP file. So static void, and then we're just going to call this end of event callback. And if you recall, the two things that we need is an AK callback type. And then we also need a AK callback info pointer. All right, we'll come back to that. For now, we're going to slot that into our func. So that's just going to be ampersand end of event callback, which I misspelled. And then we're going to slot that into our second argument. The next thing that we need to do is specify what type of callback we're doing, which is going to be end of event. So for the fourth argument, that is just going to be AK end of event. So far so good, but now here's a problem. This end of event callback is a static function, which means it has no idea what the world is and it has no idea what the subsystem is. We need to be able to pass information from one location to another, and that's where our cookie is going to come in. So we could do one of two things with the cookie. We can send it the world and get the subsystem from that, or we can do the subsystem and get the world from that. We need both anyways, so I'm just going to do the subsystem. All right, so now how do we get that information from our callback info? The way that we do that is if the callback info is valid, then we're going to grab the cookie from it, which we know is our subsystem. So let's cast it to that subsystem. And the way that we're going to do this is using the reinterpret cast, since we are doing it from a void pointer to our subsystem. And then we want to get the world from our subsystem. Which, by the way, in order to get the subsystem from the world, we can do that backwards. So that's just going to be world get subsystem. And that's going to be a template function, so we're just going to pass in our audio cue system. And that's all there is to it. You could just do the onCue function from here, and all of that would work perfectly fine. But what we actually need to do is set our current time to the next allowed play time. So now we know the exact time that we need. And for this, we do need to make sure that our next allowed playtime is public. We're going to move that out of here. I would also potentially recommend doing a getter file instead of just making this public, but this works for now. And that's all that we need to do. I'm going to keep this call as well, just to make sure it's a safety measure, but this one will ultimately be more accurate in the end. So that's all we really need to do. So let's go ahead and test just to make sure that we didn't do anything wrong. Sounds perfectly fine to me. So that's our audio cue system at its most basic form, but we can go further than this. What if we want to prioritize certain sounds to play in the queue faster than ones that were already in the queue before it? Or what if a sound is in the queue for way too long? Do we want to keep it in the queue for that long, or do we want to discard it? Let's try that in the next video.